Thank you all for joining me today. I'm super excited to be here to talk about in this API conference. You are all here because you understand how important our APIs are, how critical our APIs are. API enables every business and API enables every customer experience. There can be internal API or external API, but every customer experience which our customer uses are powered through APIs. My name is Suresh Kumar. I currently work at eBay as an engineering manager, and prior to eBay I was with Oracle. I handle large scale systems and modernization of the system. And today's talk is about modernization at scale, how a large scale system evolved over the time. This API powerfulness comes with the challenge, right? The APIs, when they are old and rigid and it is already scaled to its limits, we need to modernize it. So I will share my experience in how large scale system modernize it, mainly in 3 areas. One is the API interfaces, the underlying the platform, and the underlying the data store. How all 3 can be modernized without impacting any availability or any of the system metrics. And like I said, I've been in the industry for more than 20 years. I worked on large scale system and modernization in a very long time, but the way we modernized changed a lot with the recent AI trends. So earlier, it takes years to modernize it. Now, it is not the case, because a lot of tools help us to do a lot of manual work easily, so that we can move faster with our modernization. Again, it is important to be more competitive to the market. If we keep old system, it comes with the challenge. We need to keep modernizing our APIs and underlying systems as well. So, any typical system, this is how it looks, right? And there are external application who talk to your API, and the API will have some monolith backend, and there will be a monolith data store. Based on my experience, this is how the typical application looks like. Here, there are 3 big components, and these 3 big components need to be modernized and evolved over the time. So I will deep dive into how, in my experience, we approach each of these modernizations separately and evolve into a new modern systems. Here are some challenges which comes with this monolith applications or old APIs. In our case, it is XML and SOAP APIs. And high level, right, the old APIs are unstable. It can't scale to the current user needs, current scalability needs. And it is not performant, meaning the API responses are slow, and it often user complains about slow responses. And mainly the big issue is the developer velocity. These systems takes time to evolve. Even if you want to add a new features, it takes months to develop a new feature. And other limitations. Other thing is about the tech stack, right? Even developers don't like to work on the old tech stack. They want to work on a modern tech stack. So if your systems are old, then that comes with the challenge as well. So there are plenty of issues with this old system, also with the monolith application. So there is a necessity to move away from this system to modernize it. So like I said, there are 3 parts on the modernization which we approaches. One is the API, which is an interface which will be used by the customers that need to be modernized. The second is the underlying platform which powers the API. That also, if it is monolith, it need to be modernized. The last thing is about the underlying data store. Our data stores also need to scale for our system to scale. We can't keep old data store with a newer system. So our underlying data store also need to be modernized. Okay. So this is the picture, right? How the old system without modernization and the new system with modernization looks. In the newer system, there will be newer set of APIs. The old system, it was a legacy SOAP and XML APIs. In the newer system, it is modern Graph or REST APIs. And the underlying platform is monolith earlier. A modernized system will have a more microservices, again domain driven microservices. and the data store is also like right instead of monolith, it's split into multiple smaller domain related data stores. So, I mean, when we want to start with the modernization, we need to set some goals. We can't simply start with the modernization without having our like right end goal. So we set up some goals, and I mean, after the modernization, this is how some of our product performed, okay, at a high level. So availability was one of the main goal, right? Old system tend to break based on user load several times a year, but the new systems that's reduced. Also, like underlying storage capacity, since our RDBMS store was not scaling based on the user need, and now we are able to support more needs after the modernization. Also, the latency, the responsiveness, and SLA, it's considerably improved. And the main thing is about the developer velocity. Before modernization, it takes several months for us to deliver the small features. After the modernization, we should be able to deliver very quickly. In fact, like we were in a point like where we can deliver on-demand release, meaning the developer changes, the code will reflect in production immediately. So, like I said, AI is the main enabler in this. It is not just another tool, but it is part of our strategy itself. And I mean, AI help both internally, I mean, to refine our process, how we look into our code, analyze it, come up with the details, how we migrate it, help internally in various aspects. And also, like AI helped in enhancing our end-to-end customer experience also. Our APIs also evolved with AI-related things, which helped our customers as well. Okay, I mean, let's dive into one by one. Like, right, I'll start with how we approach API modernization, what steps we went through, and then we will go into the other two modernization, which is the platform modernization and the data store modernization. In API modernization, like the old system, what we have was that XML-based systems. So when you look into the industry, the old system were like working for like several decades without any issues. But we want to go after something new. We want to have something which is going to scale for at least next decade or 2 decades. Like REST is in the world for quite some time, and we evaluated various things, and then we figured out REST. GraphQL is the better option for us to go, I mean, based on competitive analysis and other things. So here are the reasons why we decided to go after GraphQL, and it reduces basically the client complexity. And one of the main reason GraphQL we choose is about the versionless. Like, I mean, we don't need to do anything for it to add and enhance the APIs. It is versionless support is helped us, and it also flexible for queries. People can query what they need, and they don't need to, I mean, over query or under query. They can fetch what they did and they wanted. So we went after the GraphQL, and so AI played an important role in this strategy. So here are the several steps like we followed. First is discovery. So basically, I'll go into the details in an upcoming slide, but the high level, there are 4 things. One is we want to understand what is our ecosystems are currently, and then create a new contract, and then migrate to the newer contract, and then people can integrate. Okay, these are 4 steps. Like I said, inventory clustering is the first step, where our API ecosystems are big. It's evolved over the years. There are multiple APIs in a different tech stack and different experiences. Some of them are REST, some of them are XML, SOAP, and then understanding our current ecosystem itself is a big exercise. Okay, so this was a manual exercise earlier, and then AI helped us to do it, meaning you pass everything you have to AI, and then that help us to come up with what is the right proposal in terms of the GraphQL or newer. I mean, first step is to understand the catalog things what you have. In these steps, the outcome is the catalog of what you have in with your system. The next is how your catalog can be transferred into newer API schemas. And again, AI helped us here, but I won't say AI does everything. Everything is human in the loop, meaning AI does 60 to 70% of the work. The remaining 30% of the work is human will do it. Okay, AI helped us to speed up, efficiently move, but it is not completely done on AI. with AI tools. Like in the contract translation, we had a lot of constraints and restriction in the old API, so we don't need to manually copy all those things in the newer translated contract. So AI helped us to do it, like what should be the enums, what should be the restriction of certain fields, all those things AI was able to translate it easily. So end of these steps, we have a complete open API spec which is ready to implement. The next thing is about this adapter. Okay? This is an important role. So when we want to develop a new API, you don't, I mean, if you want to build the entire system, it is going to take its own time to build it. So we went with this kind of adapter pattern where you launch your newer API using the old API as the backend system. So there will be new APIs which will up and running. People can start integrating with their new API, but underlyingly these APIs will power through the old system. And I mean, while the systems are evolving, so AI really helped there. Like generating this adapter, we have a new older schema and the newer schema, and then we are able to easily generate these adapters and then run it. Again, we won't be able to achieve whatever we wanted at this step, but at least it's helped us to move forward quickly to test the market, how our new APIs are performing. So the other thing is, important thing is about the documentation. That is a critical part of the API, and also like a client integration. Meaning when you are modernizing your API, you are coming with a newer set of API, your client also need to move. And if their job is difficult, they won't move it easily, like, right? You need to help them as well. So AI played a big role there as well, right? Improving good documentation, helping with I mean, how the old request can be translated new request automatically through other tools like MCP, and AI played a big role there. So at the end of this API modernization, this is how the architecture looked like. So meaning the newer APIs are up and running, and old APIs also still running. Old APIs still customer uses it. It takes time for them to migrate, but the newer API uses the adapter to power. I mean, adapter to use the old API to expose this newer API. I mean, this can be independently done irrespective of our underlying platform or data store migration. Here the backend is still the old backend. So like, right, but we are able to launch like our newer API without touching anything underlyingly. So next we will look into how we approach our application modernization. Again, the monolith application has various challenges. Like I described earlier, we went after like microservice-based architecture. The main reasons are like we want to have an independent scaling and like a faster deployment. So older API takes, even if one domain want to make changes, it takes months to make the changes. Wherein like the way the industry is moving, we want to move much quicker. So this microservice architecture helped us to achieve that. Like so we want to divide this monolith into small domain-based microservices so they can independently scale and run. So that's the reason we went after the microservices. And we used a pattern called Strangler Fig pattern for this application modernization. The reason, the main question is, or the main challenge is, your business is running, okay? Your platform is powering your business. Now you need to modernize our system. You can't bring down the system until your new systems are ready. Or you can't develop our new system in a big bang manner, like, right? It is going to fail. So we want to, without impacting the runtime of the existing system, we need to bring the new system. And this Strangler Fig pattern help us there. It's a standard pattern. So the concept is like this, like the name suggests like it's a Strangler Fig tree. It's a tree which grows around its host, and then ultimately it replaces the host. It is a similar thing here. Like you create a new services around the existing monolith. This new services is slowly taking traffic from the user, and we ramp it, test it, and we are good. Then it will replace the underlying the monolith service. That's an idea, and then it really helped us in our modernization. So the good thing is like both old system and new system works simultaneously, and like we can control like if we, based on our business metrics, and then we can control like the ramp of the newer system, or like if there are some issues, some metrics, we can ramp down. This pattern really helped us to move forward with that. Again, the steps prior to, like previous things, the strangler fig pattern, these are the steps we followed. First is identify the domain boundaries, and the second is like create a facade. This facade will help us to route the traffic. This facade can be like inside the application, inside the old monolith, or the facade can be outside the monolith, depends on the requirement. And then this facade will take care of like managing the traffic from the old system to the new system. And idea is we will build incrementally the new services under this facade, and the new system eventually migrated, and then we can decommission the old system. I'll skip this slide. This is the same thing as what we talked. Okay. So again, there are three steps we followed in the application modernization. One is like first is the code analysis. Understand, we need to understand what is our code complexity and everything to understand how it can be domainified. What are the different domains involved? How we can segregate the domain logic out of this. That's one. The second is like creating a dependency map, and then creating this individual microservices, and then migrating it. So the planning steps, we first understand our ecosystem, similar to the old APIs, understanding of API catalog. We need to understand our current system, that is about the planning and analysis. And the migration phase is creating the new microservices, and then slowly migrate the traffic. And the third step is like management and optimization phase. This is important. It is not, your steps are like your work doesn't stop when you modernize or move into the microservices. There are no more challenges in microservices. You need to manage like 10 or X number more than like monolith. The monolith was one application, you are able to manage it. Now like with microservices, there will be hundreds of services. And then we also need to manage that effectively. That is more important than just modernizing it. Also, we need to understand this newer ecosystem so that these systems can keep evolving in future as well. It's not like you modernize it, our work stops there. So we need to, our system, even if the new migrated system will become old, and then like we can't wait for that until it becomes old, right? We need to keep evolving it. So this is how after this application modernization looks like. So like we talked earlier, so the newer APIs are up and running, and older APIs are still running. There is an adapter which powers the newer APIs, which might use the older APIs in some extent, or it might use the newer evolved system. And again, like I said, the proxy is kind of a layer which will control where the traffic need to go. It can go to the old system, or it can go to the new system. The proxy can be outside the system or inside the system, depends on the use cases. In our case, it need to be inside because we are talking about two different tech stack, XML to REST, and we don't want to have this translation in every layer. We want to have it at one place. That's why we want to have a proxy inside it. So this is how our architecture looks on the end of application modernization. So the third step is the underlying the data store modernization. If you have one big monolith RDBMS based store, that definitely limits the scalability of your system. Even though you have good APIs, modern APIs, and modern microservices, but if the underlying data store is not modernized, your system can't scale whatever you need. So underlying data store also need to be modernized. And like I said, RDBMS for whole thing. Those are for specific need. Earlier we were using for everything for RDBMS instead of just transactional based ones. But newer things is we want to go after NoSQL data stores. Again, it's for a reason. I listed down some of the reasons here. It's just about the schema flexibility, and also it is better aligned with our microservices architecture. So these are the reasons where we went out to the architecture. Similar to 3 steps we followed in the application modernization, there are similar 3 steps, but here it is a little different. Now we know what is the data stored. The new schema may help to translate it into a new SQL. The first thing is defining a schema. The second thing is the data migration. So we did 2 kind of data migration. One is one-time data migration, loading the data. Also we followed some strategy called dual write, dual read, meaning when you start migrating it, you will dual write the data into a old system and new system. and you dual read it when we start with that, and you understand how the new data is behaving. If new data is same as the old data which is stored, then when you are comfortable, you enable all your experience with a new platform, and then slowly deprecate the old platform for the read first. Once the read is done, then later we can deprecate the writes. So that's the strategy we followed, and then AI definitely helped us there. Again, we have the same challenges about like optimization and ongoing maintenance. Okay, so AI definitely played a role there. So this is how the architecture looked like at the final architecture. Again, during the modernization process, like here data layer is wrapped with a service. The service will take care of handling dual write, dual read. Instead of earlier, the systems are directly connected with the data store to access the data, but this is how, like right after the modernization. But this is again modernization in progress. Once everything is modernized, this is how our newer systems are. Like we have a newer version of API, more microservices to manage, and then more granular data services. I will quickly wrap up a few things. It is not just modernization. We also need to monitor our systems. So AI helped really there, like how do we collect the metric, what kind of dashboard we create, what kind of alerts we have when the systems have some issues. So AI ops and predictive health are a main important thing. And we followed standard industry observability patterns to achieve this. And we also followed like a standard resiliency patterns, which is in the industry during this migration. These are some of the patterns which we followed. And AI not just helped on the modernization, like I said, it has also helped to enable the external APIs and its behavior. Since I don't have a lot of time, I'm just skipping this as well. And one of the important thing is it is not our systems evolving, and people also need to evolve. We need to invest in people in a lot of modern technologies, modern tech stacks, and AI capabilities as well. So one of the good thing we did is investing on people. As the systems evolve, people also need to evolve. Okay, I'll conclude this one like read. So first you need to understand what your system is, what its capabilities. Only if you know that, then you know whether it needs to be modernized, how it needs to be modernized. The visibility is the important pillar on modernization. It doesn't stop. It is not a one-time exercise. It needs to happen even if you modernize your system. You need to understand how your new systems are, so that you can keep evolving your new systems. And second is like it helped us really well is the GraphQL AI and governance. It's like GraphQL gave us like a base for us to scale like any new version, anything without much effort. We are able to scale with GraphQL. AI helped us to do a lot of things in optimization and coding. And again, the governance, which helped us to move faster. Like APIs are now these days APIs are evolving as intelligent interfaces. And again, it's futuristic, like we are thinking about how our APIs can evolve as a futuristic intelligent interfaces. That's all I have today.